All right, so let's start doing this. It says point U is the in-center. I know it's, let's blow it up just a little bit here. About right there. How's that? And actually, I got to keep it in those yellow or those green markers to be able to see it on the video. There we go. And I can write on there. Of course, I blew it up, so I'm going to have to make my point size quite a bit smaller. Maybe like that. Let's see. That's not bad. Pretty good. Okay, here we go. So it says point U is the in-center. What does the in-center mean? It means it's perpendicular to all these sides. So what's true about this point right here? Let's make this a different color. This point right here, if it's a perpendicular to all three sides. Okay? It's not a perpendicular bisector, is it? It's an altitude. Okay, so it's perpendicular to all three sides. What do we know that's true about this? For instance, what's true about this MU right here? It's equal to UP and what else? UB, right. So all three of those segments right there, I could probably go 1 point. All three of those segments are equal to each other. So it says, what is MU equal to? Well, look, if UP or PU right here is equal to 3, then what's MU? That has to be the same exact thing, doesn't it? So MU is 3. It's as easy as that. You with me? If you have these things perpendicular, this altitude right here, what does it do to the angle? Actually, I should have said this. It's not really, it's really the, I got to think back to chapter 5 now because it's been a while. What we did here is we had an angle bisector. The in-center is found by the angle bisector, right? So right off the bat, we know that the angle is being bisected. And that point right there is equidistant from all three sides. So that's why it's perpendicular, and that's why we put these little tick marks right here. So we also know that the angles are being bisected. So this angle 32 is equal to this angle right here. Everybody see that? Because it's being bisected. So they're asking for angle UGM. So here's UGM. That's the angle right there that we talked about. So if this is 32 without any math whatsoever, what's this angle right here? That's 32 degrees as well. So 32 degrees. Really no work at all. It's just a matter of understanding what's equal to each other. That's it. Angle PHU, PHU, this angle right here, that's just as easy, isn't it? Same exact situation. I don't know why I put two of these on here, but if you know one, you know the other. Problem is, if you miss one, you miss the other one too, don't you? So what's this angle right here going to be? It's got to be 33 because, again, it's being bisected, so that's 33 degrees. So that's an in-center. And, again, how do we find the in-center? We bisect the angles, okay? We bisect all the angles, and what happens? They intersect right here. And what's true about that point? That point is equidistant from the three sides of the triangle. It means all three of these are equal and they're perpendicular. Okay? Easy as that. All right, let's move on. Let's take a look at this. Circumcenter. What is that? Well, we find the circumcenter by taking the perpendicular bisector of all three sides. What does that mean, perpendicular bisector? It means it's perpendicular. It's already shown right there that it's perpendicular, but it's also a bisector. So that segment and that segment must equal each other. These two right here and these two must equal each other. You follow me? And then these two and these two. Okay, why? Because that's the definition of circumcenter. Because if you take a point, if you take the perpendicular bisector of all three sides, they intersect at a point that's called the circumcenter. Now, what's true about that circumcenter, though? We know something else. We know it's equidistant from the three vertices. So that point P is the same distance from B as it is to A as it is to C. So what must be true? Let's go different color here. What must be true about BP? I'll make this blue, all right? And then that's going to equal what? AP, and it's also going to equal what? PC. Everybody see that? So with all that stuff known, that should help you right here. So we're trying to find AS. So what's AS equal to? Oh, let's mark some stuff first of all. SC is 5. So that, let's make that red. So we'll stay the same colors. So SC is 5. BP is 7. I'll make that blue, since that's the blue ones, okay? And now let's find AS. Well, if SC was 5. Again, really no real math involved, is it? It's just understanding what's equal to each other. That's all. You don't have to really work out anything. There's no work to show on this one. You just look at it and see. If SC is 5, what's AS equal to? It's 5 because, again, this is a perpendicular bisector, so AS has got to be 5. All right, what about AP? AP, where's that? Here to here. Well, if BP is 7, then what's AP? It's 7 because all three of those blue ones are equal to each other, and PC would be 7 as well. Everybody see that? All right, so AP is also 7. Pretty simple stuff. All right, let's scooch over here and let's take a look at this one. Centroid. How in the world do we find the centroid? What did we do to find the centroid? We actually found the what did they call that? Not the altitude, the median. The median. Slipped my mind for a second. So we start at a vertex and we go where? To the midpoint, right? Median is it's in the middle of the road, right? So median starts at the angle, starts at the vertex, and goes to the midpoint of the opposite side. Let's put some numbers in here. It says UK is 15. UK is 15, that bit right there. And then EM is 24. EM is that whole thing, and that's 24. And then UD is 12, University of Delaware. There you go. Now, if you remember this, the centroid, that's that weird one where you do have to do a little math with this one. Sometimes you can't just look. You got to do a little bit of math. Do you remember the one where it had the 1/3 and the 2/3? Okay, that's this one right here. That's the centroid. So let's do the first one, CU, right there. Okay, if you remember, that's the longer segment, isn't it? Okay, the longer segment is what? It's double the shorter one. That's right. So it's double 15. So you had to do a little math. It wasn't much, but it's double the shorter one. So from C to U is twice as big as from U to K. Everybody see that? This point splits this thing into the longer one is twice as big as the shorter one. So if this is 15, what's CU? It's 30. All right? That's all there is to that. What's MU? Where is that? MU is right here. Now look at this. They tell you the whole thing is 24, don't they? And you need to find MU. MU is the shorter one. Now remember, it's half of the longer one, but it's what of the whole entire thing? It's 1/3, right? So this is 1/3 of the whole entire thing. I know the whole entire thing is 24. This is a third of it, so it's 24 divided by 3. It's 8, so MU is 8. All right? What about JD? JD, this whole thing right here. Well, what do they tell you? They tell you this is 12. That's the longer one. So if the longer one is 12, what's the shorter one? You need to find JU. Got a lot of stuff all over the place. Let's get rid of that. So UD is the longer one. JU is the shorter one. So it's what? Well, the JU, what's JU? It's 6, right? But that's not this answer, though, is it? Because JD is the whole thing from here to here. If this little bit is 6 and this is 12, then the whole thing is what? 18. Make sense? All right. It's easy. Who knows? We might finish this whole thing if they're all that easy. I doubt they will be. All right, let's do this one. Oh, this one's real simple. Look at this. List the angles in order from the smallest to the largest. It's been a while, but it's some way it seems to me that people put like the sides in order. But look, it's even underlined, isn't it? Find the angles in order from the smallest one to the largest one. Well, they give you the sides, but they don't give you the angles. What does that tell you, though? Exactly right. It's exactly the way I would have said it. The angle opposite the smallest side is the smallest angle. All right, so which one's the smallest side? RP. So which one's the smallest angle? Q is. So angle Q, put an angle symbol. Angle Q is the smallest one. What's the one that's in the middle then? R, because it's opposite to 5. So angle R. And then, of course, the largest one would be angle P. And that would be your answer right there. Angle Q, angle R, angle P. And it matters. It absolutely matters what order you put this in. Because it says in what? In order from the smallest one to the largest one. Now, you could have probably just looked at it, but if you had just looked at it, I mean, angle Q and angle R kind of look the same. It's kind of hard to tell which one is which. All right, so you really need to go by the numbers because sometimes you can't always tell. And sometimes on tests, not just my test, but other people's tests, the sides may not look anything like. You know, the longest side might look like it's the longest side, but it might be the shortest side, all right? Anyway, we've talked about that. What about this one? List the sides in order from the smallest to the largest. Well, first of all, we're missing this angle right here. Let's find this angle first. Okay, so this is 105 and this is 31, so it's that 136, right? So how do you get that one? Take it away from 180, and so what's that? 44, is that right? Okay, so I think it's important to find that one right there. So again, we're going from the smallest to the largest. So this is the smallest angle, so which one is the smallest side? TU or UT? Doesn't matter how you do that. UT. It's a line segment. All right, this is the middle one, right? So what's the middle side? TS. And this is the largest angle, so this is the largest side, so US. And it must be in that order. Okay, it's got to be exactly like that. Everybody with me on that? It's not so bad, is it? Tell you what, let's do this. Let's take this and scooch this down so I don't have that little thin black line. Kind of gets irritating. There we go. Looks a little better. Not right there. All right. Let's see what we're doing here. VU. So we got a triangle, and look what happens. It's an isosceles triangle, isn't it? 9 and 9. So when you have a perpendicular, right, it bisects the opposite side. So my goodness, they couldn't make this any more straightforward. Because look, they tell you this little segment and this little segment are equal to each other. So we got to find VU, this right here. So you got to find what first before you got to find X. So how in the world are you going to find X? Yeah, you set these two equal to each other, right? Because this is equal to this. All right, so you set them equal. So 7x plus 2, we'll do the math real quick here. So this is the first real math that you really had to do here, isn't it? The rest was pretty simple. Yep, subtract 3x from both sides, that gives you 4x. Subtract a 2 from both sides, that gives you 8. Divide by 4, that gives you 2. But that's not my answer, though, is it? You got to find VU. You got to plug it in. That's right. We do that a lot. So make sure you put it in for this. So it's 3 times 2, which is 6, plus 10, which is 16. So VU is equal to 16. Is that the answer? Yep. That was pretty straightforward. That wasn't much to that. I mean, because they told you straight up that these two were equal to each other, didn't they? All right, what about this one right here? Well, they don't tell you that this angle and this angle are equal to each other, but you could probably guess that it was. I mean, if you didn't know for sure. But there is a theorem that says this. If you have a point that's equidistant from the sides, okay, if this point is equidistant from this side and this side, it must lie on the angle bisector. Okay, so technically that's what you're supposed to know. Maybe you didn't remember that. A good guess would be, though, that these were equal to each other, wouldn't you think? Yeah, and they absolutely are. And I just gave you the reason why, so let's do that real quick. 2x minus 1 equals x plus 9. Subtract x from both sides, that gives you an x. Add a 1 to both sides, that gives you a 10. But they ask for the angle, though, don't they? Angle MFZ. MF is this one right here. So what do we do with that 10? We add it to 9, and you get 19. So that angle is 19 degrees. Make sense? It's pretty easy stuff, isn't it? So far. Well, now let's look at this. This is just yes or no. But you should do a little bit of work, okay? You may not have to show it, but you should have to do a little work. What was the rule? There's 3 of these on here, okay? When you add what up? The 2 shorter ones, okay? Yeah, the 2 legs, but I mean, if it's not a right triangle, you don't know, if they're legs or what. But you take the 2 shorter ones, okay, which is 5 and 7. You add them up. What's 5 plus 7? It's 12. Now that has to be what? Greater than the longest side. Is 12 bigger than 8? Of course it is. So is it possible to have a triangle with these three sides? Yes, it is. So you basically have a 50-50 shot at this. But if I was going to go, and I would never do this because I don't gamble, just basically because I'm too cheap to throw my money away. And I don't have that much money to begin with. But I wouldn't go to a casino and, 50-50 odds for me is not good enough. Okay, I want to know 100%. If I could go and gamble and I knew 100% if I was going to win, then I might do that. It wouldn't be much of a gamble though, would it? This shouldn't be a gamble. You should know exactly how to do this. All right, add up the two smaller ones, and if it's larger than the third one, then it's yes. So let's do this. We can do this a little quicker. 7 plus 13 is 20. Is 20 bigger than 20? No. So is this a triangle? No, it's not a triangle. What about this? 15 and 20 is 35. 35 is definitely not bigger, so what? No, that's not a triangle. As simple as that. Easy, easy, easy. Everybody should be able to get that. All right, let's look at this one right here. It says, find the range for the measure of the third side of a triangle given the measures of the two sides. All right, so these are the measures of the two sides. So what it means is, what can the third side be? Now remember, the two have to add up to be bigger than the third one, right? So what possible answers? There's not just one answer for my third side. It could be, there's a whole range of different answers for it. Do you remember how to find that range? The math is actually very simple. You add them up, okay? So if I add them up, you get what? 35. And then what do I do to them? I subtract them, and you get what if I subtract them? 15. So x, which is the third side of my triangle, has to be somewhere between 15 and 35. How do I show that? I put a little less than here, a little less than here. That's exactly what it means. It means x. It means the third side of my triangle has to be somewhere between 15 and 35. Pick one. Pick a number between 15 and 35. Let's say 20, okay? Let's try 20. Can you have a triangle with 10, 20, and 25? Absolutely, because 10 and 20 is 30. 30 is bigger than 25. You could pick any number between 30 and 35, and it'll be a triangle. Does that make sense? Try like 34. Well, what would the two smallest ones be there? The 10 and the 25, right? So 10 plus 25 is 35. Is 35 bigger than 34? Absolutely. So you can pick any numbers between here. That's how I want you to write your answer, just like that. Make sense? All right, what about this one? You do the same exact thing. You subtract, and then you add. So if you subtract, what do you get? 47, and then if you add them, you get, what, 61? So x has to be in between. Now watch how we write this. I stick the x right here, and what symbol do I put here? I put a less than and a less than. Make sure you do that correctly. If you have it in the wrong order, it's going to be wrong. This means x is larger than 47 and x is less than 61. You see that? So it means x could be any number between 47 and 61, and you can get a triangle out of that. Wow, looks like we are going to finish this test today. How about that? Maybe. I think I spoke too soon. We might be able to do one or two. Who knows? Let's do this. Compare the given measures. Have I done them all? Have I skipped anything over here? That's, yeah. Wow, this was easy test. Everybody get 100 on this? Huh? All right, let's take a look. It says compare the given measures. Look, this is 95. Okay, this is the side angle side inequality, in case you want to know why this works. Okay, because there's two sides, there's two unequal angles, and there's another side right there. Everybody see that? So it's the side angle side inequality. If you want to look it up, this angle right here is bigger than this angle right here. So guess what must be true about this side and this side? PQ must be what? It must be bigger than RQ. But let's do it in this order. Look how they want you to compare them. So what must RQ be then? RQ must be what? Less than what? PQ. So make sure that you put it in the order that they ask you to do it. Okay, some people put it the other way around. They wrote PQ is greater than RQ, and that's right, but they ask you to compare RQ to PQ. RQ first. Now, if you did this, if you did PQ is less than RQ, yeah, obviously that's wrong. Okay. Now, if you put PQ is greater than RQ, I would mark it right, but put it in the order that they ask. Okay, that's all I'm saying. All right, let's do this one right here. All right, let's see. what do we have here? We got side, side, side inequality. See how we have two equal sides? I got an equal side here and here, right? And then I've got an equal side right here, and then I've got two sides that are not equal. So let's take a look. This is bigger than this. 31 is bigger than 30. So look at the angle that's opposite 31, which would be this angle right here. So that angle has got to be bigger than the angle opposite the 30. So 30 is this one. So that's little. See how I made that big and that little? Okay, so this is the bigger angle. That's the smaller angle. Let's compare it the way they say. STR. Which one's STR? This one. STR is what to TRU? So we're comparing this one to this one. So what is it? It's greater than. So angle STR is what? Greater than angle TRU. And that's what you do. Okay? Since that side was bigger than this side, you look opposite. So the angle opposite the bigger side is bigger than the angle opposite the smaller side. See it? That's 31, that's 30, so this angle is bigger than this angle. All right, last one. Can't believe we're finishing this in one period. R and T. Let's real quick. This is bigger than this, right? So R is what? Smaller, right? So R is what? Less than angle T. All right, we'll do the same thing, but we'll do it tomorrow. We'll do it chapter 6. So I'll probably just do the same test for the 5th period class. So the 3rd period, we finished the whole entire test. So there you go.